Well, we've been doing a lot of work on this tender design and getting space, and I had I had a design for an adapter that I printed out. That was based on cavity design. This is a mock-up B, where I lay the components in and looked at the height and the width and all of the dimensions that I had. This was my second idea. This was my first. Yeah, this is A. And I had to make a little more room than this one would allow. And we had just completed a big walkthrough. These are a block of the program that runs inside. We have the setup, the logic, loops and setups, and then interrupts, and this is the programming part that dictated the components. And then, as you know, when you saw that, you saw how we tested it over here in this wiring board, and we really wanted to put it together in a machine, right? So we had the platform. Then I needed to build a little stand or a little holder for the computer board, which I just completed a mock-up of doing that. And I wanted to make sure, if at all possible, this would fit in the standard American Flyer tender. I wanted it to go into this tender if at all possible. And it looks like we got it. It looks like we can do it. These are what I call buck boards. They're going to take 20 volts and break it down. This one's going to be 5. This one's going to be 9. This one is to control all of this stuff, and this one is to put the heater out like we did in the last design. Under here, a tiny little amplifier speaker board, and the speaker is going to go here. This speaker is the one that I have, but it's too big. I have others. Okay, don't get excited. I have other speakers, or we'll make one fit that cavity. You have to be cautious. There's a lot of stuff in there, but there is room for a speaker. And then on the bottom here is the motor control board, and on top is the I don't want to say PC, but it's microcontroller. It's a control board. This will be the antenna, and we may put in a little wired antenna to run it outside. This is the A to D converter, and then that plate will be the exchange. D comes in, I'm sorry, AC comes in and DC comes out and goes out to the various pieces. And it's wired. It'll run on the standard trucks. This is the standard chassis. If I'm careful, I can lift this up. That's the standard chassis. This plate goes on. It's really thin. Then the body goes on. You're wired up, right? We got to add the speaker yet and the wiring. This will sit down. There's lots of room around it. We still have this vent for the heat to come in and out. The only challenge is finding a speaker. Now, I have some. I just need to test them. And what we're going to be doing next is building more software to test and getting sure that the two boards, the base controller and the engine controller, are able to pass information. We know they have. We've done it. We just want to do it on this particular shape and style and design. But I really wanted you to see the packaging because I'm very happy with it. I think it's pretty exciting, and it fits in the tender, and we just need to make sure we have room for a speaker, and I'm a little nervous about that, but we'll see. We'll find a way. If worst case, not this speaker, but a speaker could be bolted underneath, a thinner, wider one, so it still has good sound, but it could be bolted on underneath. And we're going to be using everything as stock as I can, with one exception on the engine. Well, don't look at everything on the engine. The lid burned out, as you know, and I found one of my conversion lids that is made for the Flyer smoke. So we have this smoke in. This will work. I put a plate here to hold a limit switch, and this will give us a chuff trigger, so we can also augment the chuff sound with the digital chuff sound, which is a lot deeper and more richer. And these leads will go back to do that. And then later on here, we have, oh heck. Well, we have one. It's a microcontroller. There it is. That's a controller. What do you call it? Super micro. And it would then run the engine components, lighting, and other stuff that's required. Possibly, if we go to the fan, the 3D printed fan smoke, he could run the fan, something like that. And then we have the ash pan. We got the DC fields. And then all this stuff here, this, you know, is going to be in a base unit, like we talked about, one of those tan boxes, like that box there. Oh, don't look at that. Then this is the board that's over here, and this is the board that's over there, and this is one of the buck boards that's over there. So this, and this all are going to be packaged in here and wired over the next week, my guess. We're going to have a meeting shortly about the wiring schematic and the feature set. Brought it down here. Yeah, here it is. This is the feature set that we've been working on. We're looking at doing it in two versions, 1.0 and a 1.1, just because there's more that we want to do and we may not have all the time. So here you can see throttle with the potentiometer, the switch, electric stop, heartbeat, transmissions of the packets, and optional display. And then here, some of the other stuff that we want to put into it. This is in the that was in the base unit. Okay, this is the tender. Here we have the motor driver, heartbeat, fail-safe, chuff indicator. We want to put the chuff in. I'm hoping this sensor will work for us and we'll be having it. And then we're going to play some sounds, right? And another piece of fail-safe. A couple ways to stop this thing so it won't fly off and it won't hurt itself or something else. We're also looking down the road. We want to do the heater control so I can put in my 3D printer with the heat control. Options on the chuff trigger. Once I put in my digital fan, we can go to 1, 2, or 4 pulses per revolution. We can change it. We also have lighting we want to add, and maybe some more sounds and some auto recovery stuff that we've been thinking about. And then some other part 2, more sounds, load management, cruise control kinds of things. And then some other stuff coming along. So those are the features that we've been working on putting together. And then now this is the more detailed how we build this thing out. This is the part A. So we call pin map. Each one of these little pieces up here has a number. Like here's number 4, 16, 17, 5, 18. That number means a function inside. So here you'll see general purpose IO 34. General purpose IO 5, general purpose IO 4, 2, 16, 19. All of those do something, and we assign them the function, and then we talk about where it goes and how it gets done. This is how we're going to assemble this stuff. I'll know which pin goes where, and I can route the wire and set that up with connectors and stuff. Then we have to look at the power map and how everything is grounded, how we're going to get the power in, because this is going to be on the tracks, and the only power it's going to get is going to come from here. So we have to manage that. The other device, the base unit, it can get power from the wall or from the track or from anywhere, as long as it can convert it to 5 volts. It needs 5 volts. Okay. And then we go on to some of the things we worry about on the quality and reliability. We talk about debouncing switches so that they don't, you hit the switch and you get 3 pulls instead of 1. Looking at the protocols for the networking. It's not really a network, it's a packet protocol, but it's sending and receiving, and it sends and receives a very tiny bit of information that is then structured to do a task that you've assigned that code. Okay. feedback. We want to know what's going on out there. We want to have a chance later on to do telemetry, so you could have a printout or a screen display on your base unit of heat, speed, hours run, all kinds of stuff. Whatever you think you need to know, we'll try to figure that out. I know Robert has a lot of that in his head, and so did Harvey in his system. So we're going to be looking at all these other systems and see how we can best leverage what people are doing. And then the LED displays, we've got a couple of ideas, like that yellow one there and then the tiny one. But this is the code then to set that up. There's the interface for the code. Then we go into the test sketch of the base, and this is our operating instructions for the next week. This is how we set it up. This is how we're going to run it. These are the designs of the pieces, how they fit together. And way over here is my this is how I see it. Okay, I know everybody thinks, oh God, look at that. Well, if you look at that, that's about, isn't that? It's perfect. That's a perfect implementation. Okay, now we're gonna put that over here, and then it's not gonna look like that. It's gonna be better. Okay, that's the idea. And this is like the first real thought out design for a complete open next gen S. And this is at a different level. First level 1 was all digital. This is microcontroller, so this is level 2. We're calling it Open Next Gen S level 2, and this is actually alpha version 1.0, but it'll probably just be 1.0 when it comes out, and then we'll do 1.1 and 2 as we add more features to it. But I am just really excited. I mean, we have built a lot of stuff over the last 10 years. You go to my YouTube and you'll see all of the stuff we have built. I don't think you've seen anything that comes together like this. This is what the microcontroller does for you. This is what the motor controller does for you. And this is what the 10 years of experience has done for us. We've put this together in days from that. Now, buried in here is an example right there. Now, this is the last version of Tender that I built. Yeah, just like that. That's exactly how it would work. This replaces that. This is that. These are these. And as you can see, this one's a little longer, so it has a nice speaker. I got a problem, don't I? I don't have a fan because this stuff doesn't run as hot. It won't need the fan, so I was able to push things back. Plus, I'm going to have an antenna back here. But I can't put a speaker back there. I thought I could put a speaker up here, but then when I got this plastic piece and I realized it cheats me out of that space inside there by pushing all that back. So now I'm going to have to get a thinner speaker or mount it underneath. Okay, so this is where we were level 1, and this is level 2. If I had a longer tender, you'd see a lot more stuff sitting in there. Now, in this pile, I also have an engine, if I can get it out, and I can, sorta. It's got stuff hanging off it, I don't know why, but there is an engine. And you see all of this is puff and chuff management. There's a sender trigger, right? So we're going now to use something like that trigger here. So we're going to have that trigger, this one back here anyway. But we won't have this board. We're going to have this board. Oh, and this is the 3D printed smoke. There's a fan that gives me control over the puffing. That's how you can get the 1, 2, 4 puffs and stuff. An idle fan, right? So we're going to put this stuff on. That will be level 2, 2.0 or something like that, I guess. This will be gone. I did put the board there because while this is a controller, I would replace this with this chip. That's what it amounts to. You believe that? I mean, really. That's amazing. This is what they call the Super Mini controller. Super Mini. Okay. But the brushes the same, armatures the same. DC fields that we put in, these are red. These are the old Magna Rosas, the red magnets. And this is the tender that went with this engine. Remember, I think this was an old Royal Blue is what I think it was, but I'm not sure. In any case, I want you to see the differences, because this is all level 1 control stuff, and this was all done with digitals, wires, but not a microcontroller. And when I say digital, right, it's little chips and stuff like that, but it's not a controller that runs from software. It runs from this kind of stuff, and you write it and you put it in there, and then out these little pins are instructions coming and sensors coming back in, and then other instructions go out. There's the soundboard. The sounds are in here. Soundboard. He gets told blow the steam whistle. He gets the steam whistle packet and sends it to this soundboard, and then it plays out the speaker. Yeah, I know. It's a whole new world, but I believe in it, and I think it's going to be super exciting, and it's going to change the course of the hobby, I think, because the first word of our new program, and it's on almost all the documents that I'm creating now, is open. Open. Open, meaning you can get it free. We're handing this out. We're not giving away parts, but we're handing out the knowledge and the design. So you can build this. If you want to print your parts, you'll have those files to print. If you want to assemble your components, you'll have those bills of materials to order those parts. If you want to load our program into your microcontroller, you will be able to. And we will have schematics, so you follow our schematics just like I'm going to do here in a few days. We'll you wire yours up, load it with the program, and it will do everything mine will do. You have to pay for the parts, and you have to do the labor. I'm sharing the design and the specifications, because I can't build engines. I mean, I built 3 of these engines. Where were they? Oh, it's right over here. I turned around too fast. I built 3 of these engines this last spring, and I can't do it anymore, frankly. That was it. One is that's too complicated to replicate real easy, and I can't really share this design. I mean, I could, but who's going to want to do this, right? But this guy, I'm telling you, it's not that many wires. It will not look like this. It will not look like this. It'll look like a modern car. It'll look like a modern car that doesn't have any options. So it will be pretty slick. I'm pretty sure it'll be slick, and it will run really good. This gives us very strong low speed torque using pulse width modulation. You could put 4 amps out at 4 volts or 5 volts. So you're crawling and you're pulling 10, 12 engines in 1 and 2 miles an hour, which is going to be pretty doggone exciting. Okay, I didn't mean to go on and on, but that's what it is. It's 4 o'clock, so I got an hour and a half. I can do something. We'll see what we got in mind, and I'll get cranking. Hope this was enjoyable and you understand what we're up to, why we're doing it, and why I get excited about it. Tear up my model here. Yep, we are going to have a ball. We are going to have a ball. Okay, later, gang. Take care of yourselves.